Hi, my name is Cătălin Kelmuș, and in the past 4 years I was leading the two-space team from Politehnica Bucharest. And this year in 2026 we are going to the last edition of Latin American Space Challenge. This year we are going to the most ambitious rocket ever made by our team. Project Teddy is the first one with the bi-propellant rocket motor. Our team is based in Campus Research Institute, where we are developing entirely our rockets, from the design to the testing, prototyping, and after that preparing and launching our rockets in the international contests. Now we are set the line to develop our most ambitious rocket, Project Teddy. That will be the first rocket from the two space past rockets that will be powered by a bi-propellant motor.
The main role of the air brake system is to decelerate the rocket with the goal of reaching the target apogee. This system has been used in the past for Project Luna, Project Nor, and Project Yoda, this year being the fourth iteration. And the system is based on older system used for Project Luna.
The recovery system was developed to ensure reliable parachute deployment through a redundant architecture combining a pneumatic ejection system using a high-pressure compressed air with backup pyrocharge with black powder. The compressed air is stored in a cylinder and will be actuated by a high-pressure solenoid valve. The previously mentioned systems will ensure the ejection of the cone, and it will deploy the drogue parachute when the rocket reaches the apogee altitude. The parachute configuration consists in dual deployment, and the main parachute will be deployed when a rocket reaches an altitude low enough by using an L3 tender descender.
The electronics module must handle several tasks, such as activating the bi-propellant engine and handling the rocket's recovery system using the onboard data. It plays a key role in the rocket's flight profile and its safety.
The bi-propellant rocket engine, fueled by Antonov CH4, develops a 4.5 kN thrust force operating at a chamber pressure of 30 bars. It is a pressure-fed system, meaning that when entering the system, the propellants are gases, and we are manufacturing the engine by using SLM technologies and the Inconus 118 for its thermal properties. Also, it features an ablative cooling method, and for the injection, we used a pintle injector specifically designed to operate at high flows and high pressures. But our propellants on the pipes are at ambient temperature to reduce the complexity and the storage requirements.
We use a test bench that is designed and manufactured to record the motor's thrust, pressure, and temperature before the injector, and to have a safely placed to hot fire test it. To record the motor's thrust, we use a static and a dynamic part. The dynamic part pushes against a load cell placed on the static part.